Okay, so in this problem, we want to prove that PC is congruent to QB. So I'm going to set up a two-column proof here. So before we really get into this, I want to point out that my proof is different than what's in the book. The book assumes that you did some work in 4.8, so it's using the idea of coordinate proofs. And so I'm proving it a different way, and also my proof is not really complete. So if you have something a little bit different, that is okay. Okay, so I first want to show that PB here is congruent to QC. And I'm going to use the given part that AB is congruent to AC and that P and Q are midpoints of those segments. And so this is, I probably should include additional steps to show that these really are congruent, but I'm just going to use the idea since P is a midpoint of a segment that is congruent to a segment that Q is the midpoint of, that PB and QC have to be congruent to each other. So now we can see that those two segments of the triangles are congruent. Now I want to work towards showing that this angle here is congruent to this one here. And I'm going to use the idea that triangle ABC is isosceles. So isosceles triangles, the base angles are always congruent. So I'm just going to say that given it's an isosceles triangle, angle PBC is congruent to angle QCB because of property of isosceles triangles. Now I can mark those two congruent to each other. So the other side I want to focus on is the bottom line for each triangle. And that's just that BC is congruent to CB, and that is a reflexive property of congruence. Now I can say that those two triangles are congruent to each other because of side, angle, side. So side, angle, side. Now that we know those two triangles are, we've proven that those two triangles are congruent to each other, we can now say that PC is congruent to QB because the corresponding parts of congruent triangles are congruent.